Good afternoon, everybody. I am from Münster, from the Institute for New Testament Textual Research, and I work on Coptic New Testament. I will give you first a very brief overview of what the project in general is about, which has nothing to do with paleography. And after that, I will introduce you to the work, including paleography, that is going on in the Coptological department of the INTF, which is run by a colleague of mine, Siegfried Richter, and myself. So, the long-term project, Novum Testamentum Graecum, Editio Critica Major, short ECM, has been based at the INTF Münster since 2007. The ECM is a new edition of the Greek New Testament, taking into consideration for the first time all available manuscript material and working with newly developed digital methods, among them the coherence-based genealogical method, if that means anything to you. According to these new standards, the Catholic letters were published in its second revised edition in 2013, followed by the Acta Apostolorum in 2017. In its critical apparatus, the edition includes the versional evidence of the Latin, Syriac, and Coptic traditions, and some minor versions like Gothic and Ethiopic, as well as Greek patristic citations where, quote, it can possibly contribute to establishing the Greek text or to its history, end quote. This is what a page of the ECM of Acts would look like, where it's the upper part of the page because it's too large to fit on one slide, and it has at the top the guiding line with the word addresses and the variants underneath. And this is the lower part of the page with the critical apparatus. And what follows the Greek text of a variant are the manuscripts and witnesses, including patristic citations, all that, which support one variant. So, for example, here we are in Acts chapter 2, verse 17, concerning the variant passage 6 to 12, so the words here, entais essetais hemerais, and we see here Coptic, Bohairic, and Mesochemic go back to this Greek variant, while variant B, we see here Sahidic dialect goes back to variant B. It has only metatauta instead of entais essetais hemerais. And for example, down here, variant D, we see it's a little small, but it says SMS, which means one single Sahidic manuscript goes back to this reading. So this is not very relevant to you, but it's important that you see the larger picture because this takes up a lot of time that we don't spend our entire day doing this, but pretty much of that. So in order to be able to match the Coptic tradition into the apparatus of the ECM, it is first of all necessary to collect all the relevant manuscripts and transcribe them, but I won't talk about transcription, only about collection. We collect the manuscripts in our SMR database, which was created in 2010, based on approximately 400 items that were compiled in earlier works by Alan, Schmitz and Ming, Schmitz again, and Schüssler. And the SMR database of Coptic New Testament manuscripts, how it's officially called, is the first digital collection of Coptic New Testament manuscripts. Here you see the version that we use for our daily work, which is in a program called FileMaker. Hence, the slide says offline version. I'll explain that in a minute. And starting with the mentioned 400 items, this database was significantly enlarged and counts more than 900 items today. Approximately 600 of them final numbers, and the others are still in need for some more work. Among that, the search for relatives, which is the procedure that I'll explain in a moment. And this database aims at containing every Coptic manuscript that is a witness to the New Testament, however fragmentary, so a manuscript might be just a little piece of confetti. It includes manuscripts in Sahidic, Fayumic, Mesochemic, Achmimic, and some other minor dialects. Bohairic was excluded for the time being because the large number of manuscripts is much more than we can handle at the INTF, but for the text critical work I just showed, we use Horner's edition of the Bohairic New Testament. And we systematically search all available literature, such as inventory lists of museums and collections, catalogs, excavation reports, papers of all sorts and editions, for relevant manuscripts that are still to be added to the database. The design of the digital database had the purpose to make the available data accessible in a clear and easy way, and to give information on SMR numbers, Biblia Coptica numbers, Horner, Ziegler, Gregory Arland numbers, repositories and inventory numbers, as well as Bible passages accessibly and searchable very quickly. So you see it's loads of numbers, and in fact the database was in the beginning meant as a concordance for all these numbers, but it quickly grew to become much more. Please note here that the SMR number that is assigned to every manuscript will be referred to in the future also as the LCBM number down here, because together with our partner project in Göttingen, which is the complete digital edition and translation of the Coptic Sahidic Old Testament, we now have a joint reference system to manuscript, which is the list of Coptic biblical manuscripts, so LCBM. But the ZA 108 that you see here will for eternity be ZA 108. It will just get the additional label of LCBM. Besides, the database includes information about material, codicological details, origin, and dates assigned in the secondary literature, and it's fully searchable in every box you see. All of what you see is for the internal use at the INTF and represents the current stage of research, but there is an online version available that you can access via the INTF's website, down to the right, SMR database, and it leads you here with introduction, news, and updates, and you can click on Recherche, research here, and it leads you here, and there it is, and you'll find your way around. And by the way, the online database only includes the about 600 final numbers, and not the ones that still need to be searched for relatives. We have to go back to this offline version for a moment, because I want to draw your attention to the box here in the middle, which holds information that will become very important in a minute. Here are listed the number of columns that a manuscript has or had, and if only one column survives, but originally there were two, it's noted here, as is the case here. We also record lines per column. On the left, the number that survives, and on the right, it's calculated if the columns are broken off, which is a delicate matter, but it's the best we can do. We also give the average or minimum, maximum, or approximate number of letters per line here. This helps us with the task that I'm now going to explain, which is the search for relatives. The task of expanding the database by adding new items can be a challenging one. Manuscripts are scattered all over the world. They are in pieces. They need to be put together again, and it's not seldom that parts of the same page of a codex are in different museums or collections. This is not the case for Coptic manuscripts only, but I think Coptic can be extreme for that matter, because here I always take the 35 as an example. It's a bilingual manuscript, and this large yellow box lists the places where the manuscript physically is today. And you see from top to bottom, it goes from Naples to Paris to Oxford, Louvain, Paris, Vienna. We have Washington, London, we have Moscow here in the middle, Cambridge, so it's pretty torn. And therefore, newly registered items need to be checked according to codicological and paleographical features if it might be part of a manuscript that is already registered. Because if we find a new fragment in some basement of some collection, it might be part W, X, part Y of this manuscript. So for every new fragment, we search for other fragments or manuscripts that belong to it, and we call this the search for relatives, but we specifically aim at joining fragments that are part of the same manuscript, so not only looking for paleographical similarities or relations. I will walk you through this process with an example, and as an example, let us take this new piece that is to be added to the database. It's a single folio in the National Library in Vienna, K9244. It contains parts of Acts in Sahidic. It's parchment written in 2 columns with 34 lines per column and approximately 9 to 13 letters per line, but never mind the numbers. I then take a copy of the entire SMR database and I remove and delete from this list all items that cannot be part of the same manuscript as this new piece. Namely, I remove everything in another dialect, obviously. I remove everything that's not on parchment, and everything that is written in 1 or in 3 columns. Then I thought out everything that does not really fit concerning lines and letters, so everything with significantly more or significantly less lines per column will be deleted. Naturally, I have to account for differences in layout that a manuscript can have. A codex can have more lines per column in the beginning rather than in the end, or the other way around. The limits of what to delete and what to keep as potentially related manuscripts are difficult to define as a rule. I mostly go about ±5, but it really depends on the specific case. And I try to be careful and not delete anything that might be relevant. Also, if the new fragment looks peculiar, for example, if it's not clear if it's written in 1 or 2 columns, lectionaries, for example, are written in 1 or 2 columns alternating. That can happen. We are very careful with the metadata. What then remains in the database are possible relatives that fit the new piece concerning the codicological features of page layout. And this is where paleography comes in. The candidates undergo what I call a quick check, a comparison of the new fragment with a paleographical database that looks like this. It has an entry for almost all registered SMR manuscripts and holds letter samples of alpha, beta, epsilon, mu, hori, and a line for miscellanea, anything that is particularly characteristic of the manuscript. So I put the photo of the new fragment next to the database, and I compare it to the letter samples of the manuscripts from the list of the possible candidates. So I don't compare the new piece to the entire paleographic database, so not against everything that we have, but only with those pieces that were deemed similar concerning the metadata. For our new piece, K9244 on the left, it's quite obvious on the first sight that this does not belong together, and I would delete that manuscript to the right from the list of possible candidates. While this already looks much better, and the letters in the red boxes are cut from the larger picture to the left to make it clearer what we have here. We know that there can be differences in a scribe's handwriting from the beginning of a codex to the end, and even the same page can have slight variations in letter shapes. And we try to take that into account, and it's also why the paleographic database has 3 samples of each letter. And when I notice there are different shapes, I try to catch everything and put it in the database. It must also be considered that the smaller the new fragment is, the larger is the possibility that it doesn't include slight varieties of letter shapes that the manuscript it represents actually had. And we're missing that, but that's the way it is. We can't overcome this problem. We can only work with what we have. And we are careful and reluctant, and we don't want to join manuscripts when it's too questionable. Of course, a more or less slight uncertainty always remains, but we surely go with the premise that it's better to reject a genuine match than to accept a false one. The metadata check and the quick check together save a lot of time, since we only look at essential elements and we can't get lost in things that might be interesting but are not relevant for our quest here, which is the joining of fragments from the same codicological unit. The manuscripts that are judged similar with this quick check, like the one here in the database to the right, proceed to what I call the full page check. And it's really terminology that only I use here. I don't want to create the illusion that it's some widely known method. It's only I do that. But the terms are handy. So this full page check is a comparison of the new fragment against the whole page or the whole fragment as it is of the registered SMR manuscript, so as to have not only the letter samples, but an impression of the whole page, including initials and line management and all that. A table of comparative description will be made for every full page check, and it looks like this. I describe the letter in the new fragment in the first column and the letters of the registered fragment in the second one, and I come to a conclusion about every single element in the third column. And I also take into consideration the entire layout, like the line management, if the right side of a column was neatly finished at the same line, and initials and everything that that catches the eye. And I come to a general conclusion based on these single elements about whether or not these two items are related or not. With these tables, we do not use any typology of the letters, so we don't categorize like sloping or Alexandrian majuscule. We just work with the concrete letter shapes, and that might seem a bit simple and even rudimentary, but it works. And in the present case, we found that actually the new piece from Vienna is part of this manuscript ZAR 383, and it's now listed as part F of that manuscript. The written tables are for us a kind of quality assurance, because we put down our results and the development of how we came by it, and it makes our decisions comprehensible and we think maybe reproducible. So we have more at hand than just, oh, we thought it looked similar, so it's the same number now. Most searches that we undertake end up with no result found, which is by itself a satisfying result. And most fragments get their own SMR or LCBM number. But this procedure is necessary to make sure that we don't register as different manuscripts parts that belong to the same codex. And occasionally we do find a match, as in the showcase here. And the several matches that we have found between manuscripts and that we regard as quite secure are described in a paper by two of my colleagues in the Journal of Coptic Studies. And the latest news and updates can always be found on the website of the SMR database under Neues von der Verwandtensuche. I'm afraid that until now my paper has been a bit off topic, since we do some kind of paleographical work, and yes, we use digital tools, but it's not digital paleography in the sense that has been around yesterday and today. It is true that our method is prone to subjectivity. How individuals see and perceive and then describe a letter can differ. And a poor photograph, distorted material, or a damaged surface, also faded ink, or issues like using a positive image for one manuscript and a negative one for the other can have an impact on the final judgment. We, of course, try to minimize the error potential, but it is, in the end, a subjective result. So considering the recent progress on digital paleography, I want to, and that's why I'm here, I want to pose the question to you. Do you think it might be possible to digitalize or automate this process or parts of it? And if so, how? Can we use computers to find similarities between letters of different manuscripts? And might that be a way of getting rid of this subjectivity? And a very important question for us, can we make the process quicker? Because I showed you the text critical work in the beginning, we need to save time. So those were my prospects when I came here, and having heard the papers of yesterday and today, I think there are already a couple of answers. So for the first two questions, I would certainly say, yes, we can. The problem of subjectivity then comes together with the problem of accuracy on the side of the programs you would use for automatic letter shape comparison. And the fourth question I would like to rephrase, so instead of can we be quicker, it would be can we be more efficient while staying practical? And with staying practical, I mean for any automatic approach you would have to prepare the images and train the programs and all that, and I might have mentioned we need to save time. So we are for the moment quite satisfied with our system because it's very reliable and we have full control over every step, which would change if we gave part of the decision-making to computer programs, which is scary, especially for someone like me who doesn't know anything about machine learning, deep learning, AI of any sort, apart from the fact that you need to train the programs, and that takes time. But I would like to hear your opinion on this. And that's it.